Okay, here is Quadratics quiz prep number 2. The problem for number 2 is 9x squared plus 3x minus 20, y equals. And we're supposed to find the x-intercepts, y-intercept, line of symmetry, vertex, concavity, sketch a graph, and check our work. So I already marked the a equals b equals c equals. And this could be a quadratic formula problem, but I'm going to tell you it's actually special big X. So since I already marked all my A, B, and C, I'm going to draw my special big X. 9 times negative 20 is negative 180, and then I'll have a 3 for B. So you're looking for factors of negative 180 whose sum is 3. I'm not going to do all of these because there are many of them, but I'll kind of get you started. You would look for example, 180 divided by 2. You know how I do it? I do 1 times blank, 2 times blank. And 2 into 180 ends up being 90. And 2 times 90 equals 180, but if I made like a positive 90 and a negative 2, I wouldn't get 3 if I added those. So 3 into 180, if you know that 3 goes into 18 6 times, you know that that would be 60. And again, negative 3 times 60 would get me 180, but if I put 60 and negative 3 here, their sum would not be 3. So I'll go on and do it with 4, 5, 6 until you find those factors. So I suggest that you pause right now and come back when you found the factors. So after several attempts, you hopefully came up with positive 15 and negative 12 as the factors of 180. 15 times negative 12 is negative 180. 15 plus negative 12 is positive 3. Since this is special big X, I'm going to bring down my 9x squared and bring this down as positive 15x, this down as negative 12x, and the negative 20 from the original equation comes down. And this is all equal to 0. I should have done that in the first step, that equals 0. Now I'm looking for the greatest common factor of the first two terms. And the greatest common factor between 9x squared and 15x is 3x. 9x squared divided by 3x is actually 3x. 15x divided by 3x is 5. Now let's just check. Is 3x times 3x 9x squared? Yes. 3x times 5, 15x. Bring down this negative. What's the common factor, greatest common factor between 12x and 20? That would be 4. So I'm going to act as if I'm factoring out a negative 4. So negative 12x divided by negative 4 is positive 3x. Negative 20 divided by negative 4 is positive 5, equals 0. If I multiply this back, I would get negative 4 times 3x is negative 12x. Negative 4 times positive 5 is 20, negative 20. Now I'm going to factor out my 3x plus 5. And I have remaining of 3x minus 4 equals 0. Now I set each of these factors equal to 0 and solve for x. Subtract 5 from both sides. 3x equals negative 5. Divide both sides by 3. And for this one, x equals negative 5 over 3. For this one, 3x minus 4 equals 0. I add 4 to both sides. I get 3x equals 4. Divide both sides by 3. And for this one, I'll get x equals 4 over 3. Since I'm looking for x-intercepts, I'm going to write those as ordered pairs. Negative 5 over 3, comma 0, and 4 over 3, comma 0. And on your paper, please mark them very clearly as x-intercepts. And probably box them. It's the second bullet point, but it does say to check your work for the x-intercepts by substituting into the original equation. So let's go ahead and check these and do that fraction work. I'm going to move quickly for the sake of the time on the video. I encourage you to pause the video often and do your own work and just check it with mine. So in this instance, I was saying that when y equals 0, x will equal negative 5 over 3. So I'm going to test that. Negative 5 over 3 squared, notice the parentheses, plus 3 times 5 over 3 minus 20 should equal 0. I'm going to go ahead and put that 9 over 1 because I'm going to have to multiply by a fraction. When you square a fraction, negative 5/3 squared is the same as negative 5/3 times negative 5/3. So that's just like 5 times 5 on top and 3 times 3 on the bottom. Because a negative times a negative is a positive, this ends up 25 over 9. Oh, that's supposed to be negative 5/3. Did you catch that? So here I'm going to put this 3 over 1. And I'm going to have 3 over 1 times negative 5 over 3, and then minus 20. Now, remember I taught you about cross-canceling. You can simplify before you multiply on the diagonal, as long as you're simplifying a numerator with a denominator. If it's in a multiplication problem, you're good to go to simplify. So I'm going to say that I'm going to divide top and bottom by 9. So this one becomes a 1, and that becomes a 1, and it turns out that I just get 25. I could do the same thing here. I mean, I could get negative 15 over 3 and then simplify that, or I can simplify now by dividing top and bottom by 3, which makes this a 1 and this a 1. So that becomes negative 5 minus 20. And this is going to work. 25 minus 5 is 20. And 20 minus 20 is 0. So let's check our other answer. Our other answer was positive 4/3. So 0 equals 9. I'm going to put the 9 over 1 times 4/3 squared plus 3 times 4/3. I'm going to go ahead and put that 3 over 1 because I know I'm going to have to multiply it in a minute, minus 20. To square this, it's 4 over 3 times 4 over 3, which is going to give me 16 over 3. This, I can go ahead and multiply right now. I could say that it is 12 over 3, or I could go ahead and cancel these 3's and just say that that's the number 4. Minus 20. Oops, that was a 9. 16 over 9. 4 over 3 squared is 16 over 9 because it's 4 over 3 times 4 over 3. These 9's cancel. 16 plus 4 minus 20. That works. So I have checked both of my x-intercepts, and I have verified that they work. Be sure on your paper to clearly mark that you were checking your work. So let's find our y-intercept next. To find your y-intercept, you set x equal to 0. When I set x equal to 0, I get y equals 9 times 0 squared plus 3 times 0 minus 20. So y would equal negative 20 when x equals 0. So my y-intercept is 0, negative 20. And that works because it should be 0, comma c, which in fact it is. Now I'm supposed to find my line of symmetry. And you should memorize that equation. It's negative b over 2a, x equals negative b over 2a. Negative b would be negative 3 over 2a would be 2 times 9, because there's my a, equals negative 3 over 18. Simplified top and bottom. Negative 1 over 6. Now, when I go to graph that, I'm going to need to make that into a decimal probably. But for now, we're going to leave it as negative 1/6 to find our vertex. So our vertex is negative b over 2a, and then the y value that goes with that. So I'm going to do this over here. Y equals, and the negative b over 2a is negative 1 over 6. 9 over 1. Negative 1 over 6 squared plus 3, I'm going to put it over 1, times negative 1 over 6 minus 20. Y equals, notice it's not 0 now. I'm solving for a mystery y. I already know my x is negative 1 over 6. I'm trying to find a certain y. 9 over 1. Negative 1 over 6 times negative 1 over 6 is 1 over 36. I could go ahead and multiply these. Actually, I can cancel. I could make this negative 3 over 6 and simplify, or I could say I can divide top and bottom by 3. That would get me a 3. 6 divided by 3 is 2. 1 times negative 1, 1 times 2, gives me negative 1/2 minus 20. 9 and 36 simplify. So 9 divided by 9 is 1. 36 divided by 9 is 4. So now I have 1/4 minus 1/2 minus 20 equals y. So I'm going to need to make this into fourths. So I have a common denominator. Times 2 times 2. So that's 1/4 minus 2/4 minus 20. That equals negative 1/4, oops, negative 1/4. I should make 20 into fourths, so let's make this 20 over 1. Multiply top and the bottom by 4, minus 80, because 20 times 4 is 80, over 4 equals negative 81 over 4. And again, I'm going to use a calculator when it's time to graph that. And I think we found everything it asked for, so it is time to graph. And for our graph, we're going to use all the points that we have found so far. And I'm going to look at my graph. I'm going to have to use a calculator for this vertex. And when I use a calculator for the vertex, I'm going to round to the nearest tenth. This is negative 0.2 when I round, and this is negative 20.3 when I round. That's my vertex rounded and made into decimals. And then again, hopefully you're pausing and doing some of this work and then just checking with me. When I do my x-intercepts in the calculator, I get negative 1.7, I think here, comma 0. And this one is 1.3, comma 0. So I'm ready to graph, and again, I'm sketching a graph. So the idea of a sketched graph is that you're just showing the important parts of the graph. So I know that my y-axis has to go all the way down to negative 20.3. So I'm going to call this negative 21, call this negative 20, because I'm going to need that. So my y-intercept is 0, negative 20. Put a point there. Then my x-intercepts are very close to the x-axis. Negative 1.7, comma 0. And positive 1.3, comma 0. My line of symmetry is negative 1/6, which is approximately 1.2, or is approximately 0.2, sorry. So that's going to be very, very close to the axis. My vertex is going to be negative 0.2, negative 20.3. So it is very close here. I can reflect this point over here because it was 0.2 away. So I can say that this point is negative 0.4, comma, negative 20. And then I'll connect my dots. And you'll notice that this is a very narrow parabola. It's stretched, as we call it, and that's because the coefficient of A was very large. When you have a large coefficient of A, your parabola gets very narrow. And I forgot to write down the concavity, but this is concave up because A is positive. Okay, that was it for number 2.